Okay, so this is problem 10 in your study guide. This is chapter 10, talking about the mole. This problem says a sample of a compound contains 7.89 grams of potassium, 2.42 grams of carbon, and 9.69 grams of oxygen. And we need to determine the empirical formula and the molecular formula of the compound. So we're going to do the empirical formula first. And doing that, we need to use these given masses that they give us and converting those into moles. And we do that by taking the grams, multiplying it by 1 mole over the molar mass, and that's what we find on the periodic table. So potassium is 39 grams, and you'll find that on the periodic table. So then we take 7.89 divided by 39, and we get 0.2 moles of potassium. Okay, so we're going to do that for the next two. For carbon, we have 2.42 grams of carbon multiplied by the molar mass, 1 mole of carbon over 12 grams of carbon, which is, again, found on the periodic table. And, you take 2.42 divided by 12, you get 0.2 moles of carbon. And again, I forgot to do this, but you want to, it's important to cross off your units that cancel. So the grams cancel each other out, and that's why we're left with moles. So lastly, we have 9.69 grams of oxygen, and we would multiply that by the 1 mole of oxygen over 16 grams of oxygen. So 9.69 divided by 16 gives you 0.6 moles, and that's of oxygen. So these numbers, these decimals that we actually have here, would be our subscripts if we wrote out the empirical formula. We would have potassium, 0.2, carbon, 0.2, oxygen, 0.6. But we cannot have decimals in a subscript like this. We can't have the 0.2 or the 0.6. We need to have whole numbers. No decimals, no fractions, nothing like that. So in order to get that, I want you to think a little bit of how we could get to making these whole numbers. One way to do it, and there's different ways you could do it, is by taking each of these values and basically just moving the decimal 1 over to the right, which is multiplying them by 10. You would move the decimal 1 to the right, and as long as we do the same thing to each of them, then we're fine. So that would give us K2, C2, O6. Okay, so is that our empirical formula? No, we need to reduce this. We need to bring it down to the simplest form. So we can reduce all of those basically in half. So that would give us a final empirical formula of KCO3. So that is our empirical formula, the steps involved. I hope you have kept all of these steps as you're writing them down. Don't erase like I have to here, but keep everything written down. This is a good example for you. So now we're going to move on to the molecular formula and finding that out. And that's where we use this 198.22 grams per moles. That's where that comes into play. So we take our 198.22 grams per mole. That's our sample molar mass. And what we do with that, first of all, we need to find our formula weight of the empirical formula. And how we do that, it sounds complex, but all you're doing is taking each element that's in this formula and adding up the masses. Basically, oxygen, since there's 3 of them, we would do 3 times 16. Okay, so you would add these all up, 39 plus 12 plus 16 times 3, and that will give you 99 grams. So that's our formula weight. That's what we have in our empirical formula. And I don't know if I've said this before, but the empirical formula is your most simple form of the formula. Molecular formula will actually tell you how many molecules are in the sample or in the actual molecule itself. So in order to find the molecular formula, next step would be taking the sample mass, the 198.22, and dividing it by our formula weight. And that'll give us a weight multiple of 2. So that number we then take and modify our empirical formula with that. So our empirical formula has subscripts of K, would have 1, C is 1, O is 3. So we're going to take each of those subscripts that exist in the empirical formula, and we're going to multiply it by this weight multiple, and that will give us the molecular formula. So in this case, we have K2, C2, O6. And that is the molecular formula. That's the amount of molecules that will actually be present in this sample. So there you go, empirical formula, molecular formula. I hope all of that made somewhat sense to you, and we'll talk more.